section 415. On the right side of the screen, I present to you the shape of cheating. This is what cheating looks like. Let's have a look at the actual content of this. All right, so deception includes dishonest concealment of facts, and it happens whether deception is the sole or main inducement or not. Either way, this is just going to be true. So what happens is the cheater fraudulently or dishonestly induces some party to deliver or cause the delivery of any property to any other party, or they could induce the party to consent that P2 retain any property, and that would be a sufficient definition of cheating. Or they could intentionally induce some party to do or omit to do anything which that party would not do or omit to do if the party were not so deceived, which action or omission causes or is likely to cause damage or harm to any party in body, mind, reputation, or property. The way to read the circuit diagram, things that connect left to right are and things that go top to bottom are or. So every time you see two boxes like this, you read an invisible or between them. And when you see two things connected left and right, you can say and, or you could just read straight through, depending on the English. So this is the shape of cheating, and this is the content of that diagram. It has the same shape. Now let's look at the actual text in L4. We'll go bring up the original penal code text. I chose to break this down at a high level. So we start by saying, okay, here's the section, and I've labeled these chunks as 1, 2, 3, and 4. And we begin by saying, what are we dealing with, right? Who's on stage, the dramatis personae? We have a cheater is a person, and that connects to this whoever word. P1 is a person, which is the person deceived. And P2 is any person. So that person could just be some new person, or it could be the cheater, or it could be P1, which is why we need to point out here that P1 and P2 are not disjoint, and the cheater and P2 are not disjoint, because by default, we have members of the same type are disjoint. The reason for that is because we don't want you to be your own sibling. It's an idea that shows up in logic. Anyway, we've got the cheater, we've got P1, P2, these are all the persons. We've got some kind of property, and we've got some action, which the text says anything. So the way this works is we have a definition. We decide that a cheater cheats P1. We know that cheater and P1 have been defined up here. They've been given to us. And so the only new information on this line is cheats. And that is the entire purpose of this paragraph. So we know that cheats is the interesting verb here. Cheater cheats P1 if deception occurs and the cheater fraudulently or dishonestly induces something to do with property, or intentionally induces something that is harmful, right? So that's how I've grouped the high-level ideas from this paragraph. And each one of these ideas can expand, right? So we're like, okay, what does it mean for deception to occur? So now we move down to this line 31. Deception occurs means that the cheater deceives P1, this person, whether the deception is the sole or main inducement or not. So as a programmer, I read this and I'm like, well, that entire clause just doesn't really need to be there because it's always true. But I understand that in law, sometimes there's a sort of centrality bias. So you need to have it there for the avoidance of doubt. So the cheater deceives P1. And if we were to break these things out, I'm going to just check these boxes here to separate the ideas. I'm going to regenerate this, so L4 refresh. That will update the sidebar. So now we can just open up the idea of cheating as its own thing. So cheating at a high level, there's deception. and then the cheater fraudulently or dishonestly induces some kind of property action or intentionally induces some kind of harmful action. And when we see this thing that says C3, C4, C2, we can say, okay, well, let's see what deception means, and we can click on this, and that brings up a mini diagram that just talks about deception. Clicking on this brings up the mini diagram that talks about property actions. So here, P1 delivers or causes the delivery of any property to P2, or they could consent that P2 retain any property. Finally, the harmful action. Cause P1 to do or omit to do anything which P1 would not do or omit to do if P1 were not so deceived, which action or omission causes or is likely to cause damage or harm to P2 in body or mind or reputation or property, body, heart, soul. So that's the shape of each one of these components, right? And this is the text of it. You can see that the keywords have, we decide this thing is true if all of these things work out to be true, and each of these individual components are connected using ands and ors, and this ... is just a connector that has the same function as an and. It's to make the English read better. So property action means P1 to deliver or cause the delivery of any property to P2, or P1 to consent that P2 retain any property, and that turns into exactly this diagram. Let's bring this up so you can see how these things match up. And then we look at harmful action. So harmful action means that P1 would do, or let's copy the link, do or omit to do anything which they would not do or omit to do if they were not so deceived, which action or omission causes or is likely to cause damage, harm, body, mind, reputation, property. And we're just connecting all of these ideas up using a simple or keyword, a simple and keyword, and then this thing is a horizontal connector which has the same function as an and. And then down here we define deception. So there's a little example at the, there's an explanation here that says a dishonest concealment of facts is a deception. So here we say we define deception as cheater deceives P1 when deception includes dishonest and dishonest concealment of facts, and this acts as an and, so you need to have both of these parts true for that to work. All right, so that's basically it. We have a couple of sort of ontological ideas down here. You'll recognize this, for example, as classic definition of a legal person, and including both natural persons and sort of corporations. Here we have the idea that an action could be a positive action or it could be an omission, and by default these things are disjoint. So if it is a positive action, it is not an omission. If it is a legal corporate person, it is not a natural person. And all of that sort of falls into the ontology that we've seen up here. So what we can now do is we can say, all right, let's jam all these things together, right? So as you turn on and off these chunks, what we're going to do is regenerate. And so now I'm going to rebuild the cheating diagram, but with deception sort of built into it. So we're going to plug this deception into cheating. It's exactly like expanding a variable in mathematics. And now we've got deception includes dishonest concealment of facts, whether deception is the sole or main inducement, or it is not. Whether or not deception is the sole or main inducement, that's this clause. The cheater fraudulently or dishonestly induces some property action, or intentionally induces some harmful action. And so now we need to plug in the variables. We need to expand out this property action. Let's do that. And click on property action and regenerate the diagram. And now number 3 is going to disappear into number 1. Very good. Let's bring that up over here. So now the diagram is getting bigger. We've moved the property action. We've expanded that into here. And now we're going to do the last piece. We're going to expand the harmful action. And so this makes the entire diagram as big as it's ever going to get. So that turns into this. Let's reload the cheating diagram. Copy link. All right, so this is the big picture now. Now, what exactly is this diagram convention? What does it mean? What it means is the game is to get from the left side of the screen to the right side of the screen. And to do that, you need to turn these things true, right? So for example, if we had some event where there was concealment of facts, but it was not dishonest, right? We would only be able to turn this true, but this would not be true, and then we would not be able to get across the pond, right? This is a lily pad, this is a lily pad, and this lily pad sinks, and this lily pad floats, right? So the goal is to find lily pads that float all the way across so you can jump from pad to pad and make it all the way to the other side. And so we've sort of productized that in the form of a little web app. So now we've got a web app that contains the entire definition of cheating based on what we've got in the spreadsheet. And we can sort of wizard our way through this, or we could have the end user look through this and try to find a way across the pond themselves. So let's pretend that there is a scenario where there was dishonest, concealment, and the inducement was the sole, perhaps, point of the deception, and it was, let's say it was dishonest, but not fraudulent, right? So we're going to click on dishonestly. And then we're going to say, okay, what did they do? They induced the delivery of property. Okay, boom. And now we've got a little path that goes all the way across the pond, and we can see how exactly those criteria have been met to constitute cheating. And you can do that. You know, you can go across the pond this way, you can go across the pond this way. Left to right is and, top and bottom is or. And so when you are looking to meet a definition, you're looking for some path that gets you across. All right, so that's L4 in a nutshell. For simple propositional logic like this, real quick is how do you label these components, right? These individual elements, we could ask, did they deliver? Or did they cause the delivery of, right? And these would lead to different versions of the answer. We could say, all right, well, if they delivered, we could say, well, 3.1.1 is true. If they caused the delivery of, then we could say 3.1.2 is true. And the relationship between 3.11 and 3.12, they're connected by an or. And so if either one of them is true, we would say that 3.1 is true, right? That's not shown here, but it is shown in 3.2 because 3.2 only has one thing. So this is 3.2, and then these things together are 3.1. And then if 3.1 or 3.2 are true, then 3 itself becomes true, right? So another example, this section, we could call that 4.1. We could call this section 4.2. We could call this section 4.3. And within section 4.1, we've got two leaf nodes. We've got 411 and we've got 412 connected by an OR. We've got same idea, 421 and 422 connected by an OR. We've got a slightly more complex situation. We've got 431 and 432 and 433. And within 431, we got 4312, 4311 and 4312 connected by an OR. Within section 432, we've got 4321 and 4322 connected by an OR. And in section 433, that's made up of 433, 1, 2, 3, 4, all connected by ORs together. So that's a standard convention for labeling things. I think it lines up pretty well with the legal convention. And so if you were to draw a data flow diagram and look at each sort of possible input to this, I think you'd have something like 30 different possible combinations of, well, you'd have combinations of 30 different possible inputs. So we might say, okay, it's a soul, it's to deliver, it's, you know, to do, it's fraudulent, right? And so you could throw up these combinations And I believe that there are about 30 different input elements. You could call them leaf nodes, you could call them input elements. So this would be one input element, this would be another input element. Whether you induce it or intentionally induce it, that's another input element, 1.3 versus 1.4. So with about 30 input elements, the total number of ways of answering this spreadsheet is 2 to the 30th. 2 to the power of 30. What's that? That's going to be some gigantic number, right? So there's a huge number of combinations that you would get. This is like a billion combinations, literally, that you could have to combine these inputs. But you could very compactly describe which ones which ones came up as true just by giving the node ID on these things. And then based on the node ID, you would get some path across the pond.